In this video, we're going to be solving a quadratic inequality. So the inequality that we're going to be working with is f of x equals 3x times the quantity x minus 1 set greater to 10 minus 2x. So the first thing we want to do is to get everything on the same side. So we can start that off by distributing our 3x. So that's going to give us a 3x squared minus 3x, which is greater than 10 minus 2x. And then we're going to add that 2x over and subtract the 10. So we're really working with a 3x squared minus x minus 10 set greater than 0. So that's our first step. Let's put that up here. Now our second step is to find our boundary points. So in order to find the boundary points, we actually want to take this equation that we just got, and we actually want to set it equal to 0. So notice that change. We're going to set it equal to 0 to find our boundary points. So here, I'm going to go ahead and I'm going to factor this. Now I like to do a Punnett square. So I'm going to go ahead and make my square. And I'm going to put the first thing in the first box and the last thing in the last box, and I can multiply those. So negative 30. So I'm looking for two numbers that will multiply to negative 30, but add to a negative 1. And I can choose a negative 6 and a positive 5 to do that. So negative 6x and 5x. And as I pull things out, I see that here this has a 3x in common, this has a 5 in common, that has an x in common, and this has a negative 2 in common. And so this is going to turn into the factor x minus 2 and 3x plus 5. And we're going to have that again set equal to 0. So I'm going to see that I'm going to have boundary points of 2 and negative 5/3. So these are my boundary points. So if I was looking at it on a number line, like here's my negative 5/3 and here's 2, right? So those are my boundary points. So something is happening here and something is happening here and something is happening here. So now the question is, what is happening? Like, where are we above and where are we below when I graph it? Like, if I were to graph it, am I below here? And maybe I'm above up here? Or maybe I am, let's use a different color. Maybe I'm above up here, but below down there. And that's what we don't know. So that's what we're going to find out. So we're going to have some test points that we're going to use. So what are some good test points? Well, we want to try to pick numbers that live inside that range. So 0 is between negative 5/3 and 2, and it's an easy number to multiply. And then a number that's bigger than 2 would be 3. And a number that is smaller than negative 5/3 would be a negative 2. So we're going to try those points out. We're going to test those points out. So that means that we're going to plug those in to this equation right here. And we're going to see where they go. Okay? So we're going to take this equation now. And we're going to have 3 times minus x minus, oh, I shouldn't say x, sorry. I should say squared, and then minus 10. So here we're going to have the negative 2. Let's test out that negative 2 value. And we see that when we plug that in, it gives us a value of 4. So 4 is going to be above the x-axis, right? So this is basically your x-axis is what we're thinking of, okay? So let's plug it into the other numbers. All right, so we're going to plug in the number 0 next, which is what we're doing right here. We're plugging that number 0. And when we plug in the number 0, that's going to give us a value of negative 10, which is going to be below the x-axis. And then when we plug in the number 3 to our equation, which is what we're doing right here, that's going to give us a value of of positive 14, which is above our x-axis. So now that we know that, we can set up our solution set. Now remember that specifically, we were looking for where we were greater than 0, right? That's what we want, is where are we greater than 0? So where are we above? That's what we want. We want our aboves. So we are above when we are on this side and on this side. So we can write that in interval notation. So we're going to go from negative infinity all the way to a negative 5/3. Let me move that. There we go. And it's not included because it doesn't say greater than or equal to right there. It just says greater than. And we're also above from the number 2 to positive infinity. Now remember that our negative 5/3 and our 2 came from our boundary points that we found, right? That's where those came from. So that's interval notation. And if you prefer to write it in set notation, you would be able to say x such that x is less than negative 5/3 or that x is greater than 2. And we've now solved this inequality.